In the race to build artificial intelligence, one company quietly became one of the most powerful technology suppliers in the world. Not Apple, not Microsoft, not Google. A company that once built graphics cards for gamers is now powering the machines that train the most advanced artificial intelligence systems ever created. This is the story of Nvidia and how it became the infrastructure behind the AI revolution. The story begins in 1993. Three engineers sat together in Silicon Valley discussing a belief that sounded strange at the time. They believed the future of computing would depend heavily on graphics processing. Those engineers were Jensen Huang, Chris Malachowski, and Curtis Preem. Their idea was simple: build a company focused entirely on graphics processors. At that time, the personal computer market was dominated by CPUs. Central processing units handled most computational tasks. Graphics were considered secondary. But Nvidia believed something different. They believed the future would require massive parallel computing. Instead of processing tasks one by one, graphics processors could perform thousands of calculations simultaneously. For video games, this meant smoother and more realistic graphics. But the architecture of GPUs had a hidden potential: parallel computing. And that potential would later become the foundation of artificial intelligence. During the early years, Nvidia struggled to survive. The semiconductor industry is brutal. Many startups fail before reaching profitability. Nvidia nearly faced the same fate. But the company made several key technological breakthroughs. One of the most important moments came in the late 1990s when Nvidia introduced the GeForce Graphics Processing Unit. The GPU concept changed computer graphics forever. Suddenly, computers could generate complex 3D environments in real time. Gaming exploded in popularity, and Nvidia became one of the leaders of the graphics industry. For years, the company was seen mainly as a gaming hardware manufacturer, but something unexpected was happening inside universities and research labs. Scientists discovered that GPUs were extremely powerful for mathematical computations. Machine learning researchers began experimenting with GPU acceleration. Training neural networks requires enormous matrix calculations, exactly the type of workload GPUs are designed for. Nvidia noticed this trend early. In 2006, the company released a software platform called CUDA. CUDA allowed developers to use Nvidia GPUs for general-purpose computing. This decision would eventually transform the company. CUDA opened the door for scientists, engineers, and AI researchers to use GPUs for complex computational problems. Over time, more and more machine learning projects began using Nvidia hardware. Then the artificial intelligence revolution accelerated. In the 2010s, deep learning models started achieving dramatic breakthroughs. Speech recognition improved. Computer vision improved. Language models became more powerful. But these systems required enormous computational power. Training advanced neural networks requires billions of calculations repeated millions of times. Traditional CPUs were simply too slow. GPUs, however, were perfectly suited for this task. Companies like Google, OpenAI, Meta, and Microsoft began building massive data centers filled with Nvidia GPUs. Inside these facilities, thousands of chips work together to train artificial intelligence systems. Each GPU processes a small piece of an enormous mathematical problem. Together, they form the computational backbone of modern AI. In other words, artificial intelligence runs on Nvidia hardware. This demand triggered explosive growth for the company. Nvidia expanded far beyond gaming. The company began designing chips specifically optimized for AI workloads. Data center GPUs became the fastest-growing part of Nvidia's business. Cloud computing platforms now rely heavily on Nvidia hardware. Amazon Web Services, Microsoft Azure, Google Cloud, all of them offer AI computing services powered by Nvidia GPUs. Some AI training clusters contain tens of thousands of GPUs working simultaneously. These clusters consume enormous electricity. They require advanced cooling systems and complex networking infrastructure. But they enable something remarkable: machines capable of learning patterns from massive datasets. Machines capable of generating language, images, and simulations. Machines that are beginning to reshape industries. And Nvidia sits at the center of that transformation. However, the rise of AI has also triggered geopolitical tension. Artificial intelligence is now considered a strategic technology. Countries recognize that AI leadership could influence economic strength, technological dominance, and even military capability. Because of this, advanced semiconductor technology has become a critical geopolitical asset. The United States has introduced export restrictions limiting the sale of certain advanced AI chips to China. These policies highlight a new reality. AI hardware is no longer just a commercial product. It has become part of global power competition. The companies designing these chips now influence the future of technology, and Nvidia is one of the most important companies in that ecosystem. Looking forward, the demand for AI computing power continues to grow. Every new generation of artificial intelligence models requires more data and more computational resources. Larger models require larger clusters, more GPUs, more infrastructure. Nvidia is designing the processors that will power this next era of computing. The company is also building complete AI platforms combining hardware, networking, and software tools. In many ways, Nvidia is evolving into something larger than a semiconductor company. It is becoming the operating system for artificial intelligence infrastructure, a company that provides the foundation on which the AI economy is built. When Nvidia was founded in 1993, few people believed graphics processors would become one of the most important technologies in the world. Today, nearly every major artificial intelligence breakthrough depends on GPU computing. Behind the algorithms, behind the neural networks, behind the AI applications transforming our lives, there are thousands of processors running inside enormous data centers, performing trillions of calculations every second. And many of those processors were designed by one company, Nvidia.